until it comes. We'll write down the question. We'll do it with the example. Subnetting. I think you wrote the subnetting as subnetting, right? And then we'll do an example. The class C network. Comma 192.168.1.0 has 254 hertz. Has 254 hertz available in it. Divide this to 4 subnets. Divide it to subnets. Subnets each having a maximum of 50 hertz. Each having a maximum of 50 hertz. Here you find the subnet addresses. Network address is given 192.168.1.0. It's a class C network and maximum 254, but we have to divide it into subnets. Each subnet should have a maximum of 50. You can't have more than 50. But 50 is not a 2 to the power 8. So you have to go for the closest 2 to the power 8 when you are doing subnetting. So what is the number then? 32 you can't, because you should have a maximum of 15, and 48 also you can't. And 64, although you are using 50, you have to allocate 64 addresses. Okay? So put a stand measurement. This 50 is not a power of 2. Take 64 as the next power of 2. Next power of 2. Then you calculate 64 as 2 to the power 1. 2 to the power 6. That means to have 64 computers, 64 addresses, you should have 6 bits reserved for addresses. 6 bits outside the must be here. Inside that 6 bits must be reserved for the first time. Total number of bits available for the host ID in class C is how many bits? 8 bits, class by. So it's a class C address. Out of that, 6 bits must be reserved for this. 2 bits is only available for subnet ID. If the subnet ID is 2 bits, how many subnets are there? Only 4 subnets. But one subnet should have 50. Then if you have 4 subnets, maximum of 200. The question says 254 computers. So that means it's not theoretically possible to subnet this into 5 networks. Because if you subnet it to 5 networks, 2 to the power 5 is 32. That means if you take one more bit out of this, suppose you take 2 to the power 5. To the power 5, then you can support 50 computers. So we run into a problem immediately, which you have to know. That means this is the problem of classful addressing. In classful addressing, you can subnet it for any number of computers you want. The maximum number of computers should be a 2 to the power number. Otherwise, some addresses will be wasted. So this is the problem we want to highlight by this exercise. So you can write. First time scale. If 6 bits are reserved, so first type is subnet. First ID is subnet. Only 2 bits are available. The 2 bits are available for subnet ID. For subnet ID system. Then maximum of 4 subnets are possible. 4 subnets are possible. In bracket, however, it cannot accommodate all 254 computers now. With the limit of 50 in one subnet. 50 maximum in one subnet. 50 maximum in one subnet. This highlights one problem of classful addressing. Highlights one problem of classful addressing. Divide your address range into 3 more. Remaining 24 bits inside. We divide the address range into 3. First 24 bits we have already given in the question. 192.168.1. It's already there. Already given in the question. Then, these 2 bits can be 0, 0, 0, 1, 1, 0. Outside it can have minimum of all zeros you can't use, all ones you can't use. number, decimal number 1 to decimal number 66. Total of 64 computers, 64 addresses. But we have to reserve the first one for the entire one. Last one has to go some address. The middle one we can. From every address range you allocate for a subnet. Very first and the very last addresses don't allocate to computer. So they are needed for special purpose. Put a sign mention there. When we make a subnet, address range, subnet address range, command the very first, you can bracket the lowest, close the bracket, and the last, you can bracket the highest, close the bracket, addresses should be reserved. The lowest one, the lowest address is for subnet ID. Lowest address is for subnet ID. The highest address is for broadcast ID. Broadcast address for the subnet. Broadcast address for the subnet. Remaining addresses to host. So that's how they are okay. 62 and this number when you convert this. Now we will define subnet mask. Subnet mask will be for 3 bytes. Whole logic 1. Let's write whole logic 1. Then write whole logic 1. Let's write whole logic 1. In this byte, 4 bytes, the first 2 bits must be logic 1. Remaining bits you have to be 0. For the bits which are going for the host ID, you must make 0. All the remaining bits you must make logic 1. That will be the subnet mask. That is the mask used by the router to decide whether it is for the local net or not. When you convert this to here, I have to put zeros. Only for these 6 bits you put zeros, 4 other bits you put logic 1 and make the mask. So when you find the mask in binary, decimal value, it is 265, but 255, but 255. That is this number. First two bits are logic 1, that means 128 plus 64. What is the number? 192. 192. Subnet mask will be 255.255.255.192. Subnet mask for the router. Then each net ID we have to find now. You can write the net ID for the 4 networks would be net IDs for the 4 networks would be subnet A. What is that? 192.163.1, that's it, is there anyway. But this is the net. These two bits will be 0, 0, all other bits will also be 0, 0. Therefore, it will be 0. First subnet address will be there. Subnet B 192.168.1. These two bits will be 0, 1. All other bits will be 0. Because minimum address, here you have to use the minimum. Because minimum all 0 address is reserved for net. So this is 0, 1, 0, 0, 0, 0 and so what is that? 64. Network subnet C 192.168.1. These two bits will become 1, 0 and these bits will be becoming 0, 0 in that byte. And when this is 1, it is 128. Subnet B 192.168.1. These two bits will become 1, 1 and other 6 bits are 0, 0. That means 192. These are the 4 subnet types. Simplification is there. These are subnets where the network will be connected. This is subnet A, B, C, D. This subnet address will be this one. For subnet we have also addresses now. Subnet mask will be, so each of the subnets same mask. range of addresses in each subnetwork, you can keep on giving addresses here. Range will be first computer 192.168.1.1, 1.0 is for the network, 1.1 for the first computer, last computer in this 25.1.63. So 64 is the next network. After that you can give, but they say only 50 will be given, and you have 60 sure. Well, addresses will be not utilized. Here you can give computer address name from 192.168.165 to 127. 63 is reserved for the broadcast. Here also 126. 63 we can't use because of the broadcast. Likewise, you can use the address range sub. The problem here is that 12 addresses in each subnet will not be used. So they say maximum available is 50. Number of computers we can put is only 200. Put a sign to 12 addresses. In each subnet. 12 addresses in each subnet cannot be used now. Because there will be only 50 computers. Only a maximum of 50 computers in each subnet. Only a maximum of 50 computers in each subnet. So that's the disadvantage. In brackets you can write a disadvantage in the classful method. You can do another example on your own, similar one. Write an example like this. The network 192.168.5.0 should be divided to 20 subnets. With 5 hosts per subnet. So that's the requirement. You can write, do the address planning. This address planning can be done by simple calculators available in the planning calculators are there in the internet also free of charge. So you might not need to do it manually, but for the exams we are practicing. Right? When you're actually doing the job, you have software to do the planning also. Right? So can you try that? So it's very similar. The numbers I have changed. That's the only thing. Right? Otherwise, it's very similar to the earlier one. You don't need to draw a diagram, just stand addresses, that's enough. A diagram of 20 lines will be difficult to draw. Okay? So first take the basic distance, that will be enough. Is 5 hosts each. You can't have 5 because 5 is not a 2 to the power. Same problem as earlier. So you have to go for 8. 4 is not enough. Next is 8. 8 means 2 to the power 3. That means the last 3 bits you will have to reserve for first side. Last 3 bits you have to reserve for the first side. Then remaining 5 bits of that byte goes for subnet allocation. Remaining 5 bits for the subnet identification. And 5 bits means 2 to the power 5, and you can go for 32 subnets. But we need only 20. That's fine. So the 20 can be accommodated. The class C network, so first 24 bits is net ID, then 5 bits for subnet identification, last 3 bits for host ID. The subnet mask you can decide here. 255.255.255.1. last byte is set to 1. Last 3 bits are 0. That is the number. When first 5 bits are set, let me go back to that table. First 5 bits are set, that is here, right? When first 5 bits are set in a number, it is 248. So, subnet mask is 255.255.255.248. The number. What when you need to write this, you can identify from 2, 3 network, rest of the logic is same. Subnet mask we already got, right? 255.255.255.248, right? And then address of the first subnet will be 192.168. What is the given address? 192.168.5.0. That is a subnet A for the first one. Subnet B will be 192.168.5.8. Then 16. Then 24. Like 24. Don't worry, if you just plan that and understood that one, that will be enough. You can plan the subnets and the net addresses, that will be enough. We'll do another exercise. Exercise, discuss what happened. When an IP 5, right? That 5 dot 35. 5 dot 35 arrive. At the router. At the router. Now we have subnetted the last subnet. Assume that a packet comes with this board. Board means it's the address it has. So what will the router do? The router will have to analyze this. So now a packet comes with this sign 192.168.5.34. 35. That's the number it has. The router will have to quickly analyze. What will it do first? What will it do first? It will do an AND operation with the subnet mask, AND operation with this number and the subnet mask. That's the first thing it does. So step 1. The router will do an AND operation. Router will do an AND operation between this address and the pre-programmed subnet mask. This address and the pre-programmed subnet mask. Can you write the two numbers one under the other in binary and do the AND operation? 8 bit by 8 bit groups you can write one under the other. Even address you can write first. (192.168.5.35). That's the address it has. So can you convert that to binary and write down? 192 in 11, then rest are 00, all 0. Rest of the bytes is 0, 0, 0. Second byte 168 means 128 plus 128 means first bit will be logic 1, that is 1. How much will be remaining? 40 will be remaining. That means you will have to go for 32. 64 is not available. So put a 0 for next bit. Next bit is 0 because 64 is not available. Next bit should be 1. 32 should be available. That's how you go on. Okay? You mark 128. Find how much will be remaining. 128 plus 40 is 168. But next bit is 64, you can't have 64. 32 you can have. 8 will be remaining. After 32, 16, not possible. 8 possible. 4, 2, 1, 4 is not available. That's the number. Fine. It is 128 plus 32 plus 8. 128 plus 32 plus 8 will be 168. Likewise, you can convert these numbers to binary. 192.168, then 5. Number 5 is 0, 0, 0, 0, 0, 0, 0. First 5 bits will be 0. After that 1, 0, 1, 1, 0, 1, 1, 0, 1, number 5. 35 means 32 plus 2 plus 1. That is 32. 1, 2, 3, 4, 5, 6, 7, 8, 32. 32, 2, 1. Just 32. Is 35. 32 plus 2 plus 1 is 35. underneath you can write the subnet mask. You have already planned the subnet mask. So write that subnet mask underneath. Subnet mask is already programmed to the router. You have to program, and then it will take that subnet mask and not subtract, it will do the AND operation. So write the two numbers one under the other, bit by bit you can do the AND operation. Bit by bit AND operation you can do. Just underneath 255.255.255. What is the number? 255 means over this one. 255 again. Again 255.
The last byte AND operation, third bit from the left, 111 and other two are 0. Again 0.
So you do the AND operation, and after that it calculates this number. It is 192. It did not change. So 192. This will not change, this will multiply, this will not change, 75. This is the only thing which will change. What is that now? 1, 2, 4, 8, 6, 7. So therefore it subnet ID. This is the ID of the subnet where that computer is. This packet will be sent to the port with this address, because this is the subnet in which that particular computer will be there. The router will calculate only the subnet and then send the packet there. You can write. Now the router knows. The router knows that this host will be in the subnet 192.168.5.32. Will be sent to that port, that physical port. So one of the physical ports will be given this address. So it will be sent to that port. So this is on the router's stack. This is the router's stack. Then within that local area network, the correct computer will have to catch that packet now, because packet has been sent now. The correct computer, that 35 computer will have to catch that from the local area. Thereafter, the destination host will assist from its local network, local subnet. Next example, the host 192.168.5.35 needs to send a broadcast packet. It will send a broadcast packet to its own subnetwork. What should be the destination address in that IP packet? What should be the destination address in that IP packet? Broadcast means you make all the bits logic 1, right? That's what the stand says. For broadcasting, make the corresponding bits equal to logic 1. Make the corresponding bits equal to logic 1. So if it is a local broadcast in your own network, what should be your destination? It should go to everybody. Then all the host, you take the host ID bits. How many bits are there? 3 bits are there, because each subnet has only 5 now, right? Only 5 computers. So only 3 bits we have used. So those 3 bits you have to set to 111 and transfer. So what will be that? If you set all the bits to 1 in a particular subnet, everybody in that subnet will take a copy. That's called a broadcast. So can you find that? Local broadcast. In any portion of the ID, you have to remember that any portion of the ID, all bits full means everybody. All bits are one, that means everybody. So you want everybody in your network. the router. You are not going out of the router. Supposing this is your local area network, router is there, you don't need your broadcast to go beyond that router. It is only within your local area. So that means you don't need to specify any net ID now. Router don't need it. So for anybody to broadcast in the local address, local area, you always use 255. All bits 1. So 255.255.255.255, all bits 1. Means everybody in my network. 255.255.255.255. That's the easiest, right? That means everybody in my local network. Everybody in my local network. Just mention that in some. It means everyone in every host in my local network. Everyone in my local network. Suppose you want to send a local broadcast to only one particular subnet, not to the other subnet. Now it has to go to the router. Now it has to go to the router. Then the net ID must be read. Otherwise router can't analyze. Next example. For directed broadcast, so the first subnetwork should be sent some other address should be now it should be directed to the first subnet. You are not broadcasting to your local network, you are broadcasting to the first subnet. You are in the fifth one, isn't it? You are just in 35. You have to broadcast to the first one. Now think what should be the destination address you should put on the IP data card. You have to write the net ID of the first network, and all the hosts means all the host bits in that you have to put 1. What is the net ID of the first? 192.168.5.0. Net ID I am changing on this. Net ID means all these are 0. That's the net ID, but all the hosts in that network will receive. That means the host numbers will be, how many host numbers are there? These are the 3, right? These are the 3. That should be made 111. So this is the net. This is subnet. You direct to that subnet. You are not directing to any particular host, because there is no host in that subnet with this address. No host. When you put all the bit logic 1, that means everybody in there. This is called directed broadcast. What is the address? 192.168.5.7, which is the broadcast address of that local network. It is the broadcast address of that local network, not your network. Not your network, other local network. This kind of a thing we call the directed broadcast. Earlier one we call local broadcast. Okay? There are different ways to broadcast packets. So you can write this directed broadcast. This is called a directed broadcast. This is called a directed broadcast to subnet A. Directed broadcast to subnet A. Next example. To broadcast datagram to all hosts in all subnets. All hosts in all subnets. What should you do? Subnet bits must be made equal to 1. Host bits should also be equal to 1. Every bit should be made 1. That means the whole last byte should have 1. 5 bytes were there for the subnet, 5 bits. 3 bits were there for the host. Everything should be 1. And that will be 192.168.5.25. 5.25. 2.168.5.25. With that address, if you send a packet, everybody will copy. Everybody in all networks will copy. So these are the techniques of broadcasting, right, with IP address. Right. Now I think it may be clear to you how the subnet addresses come, how the broadcast addresses come. Right. How many different types of broadcasts are possible? 3 different types. What are the names? Local broadcast in the local net, directed broadcast to another subnet, global broadcast to all subnets. Last one is called global broadcast. Last one is called global. Global broadcast means to everybody on all subnets. Everybody on all subnets. Local, directed, global. Those are the 3 types of broadcast you can do.
So මේකේ ලෝකල් එකයි වෙන සබ්නෙට් එකේ විතරක් යවන්න බැරිද? තමන්ගේ ලෝකල් බ්‍රෝඩ්කාස්ට් එක එතන කරලා ඒකයි තව සබ්නෙට් B හරි මොකක් හරි වෙන එක.
You can do simultaneously to your subnet and another one. You have to send 2 packets. One for your one and the other one directed to the other. Because one IP packet can't carry 2 addresses. One IP packet can carry only one address. So this is basically subnetting. We'll look at the problems with this. Problems with this method is, now we already noticed, some addresses go wasted. Because you can't subdivide to different numbers of computers. Minimum should be a 2 to the power. 2 to the power number, otherwise it will be wasted. So, when we take class A addresses, in the total address space, half the number of total addresses available in 32-bit address space will be for class A. Class B, this. Class C, half of this section, class C. D and E are for the remainder. Class C are small portion sectors. These are given for smaller organizations, bigger organizations, much bigger organizations. This is the ICANN is practicing early. And then combining disadvantages of classical addressing. Disadvantages of classical addressing. The total address space in IP version 4. Total address space in IP version 4 is 2 to the power 32. 2 to the power 32 full stop. This address space gets subdivided. This address space gets subdivided as shown below. As shown below. You can do this half of the remaining half of the remaining half for class C, half of the remaining half, and likewise gets divided to half of remaining. Because it's getting divided by 2 to the power. So it is clear that class A will take 50% of all addresses, available addresses. So you can mention this. Class A takes 50% of range. Class B 25%. Class C 12.5%. This leads to, this leads to problems. Leads to, number 1, addresses being wasted. Addresses being wasted, especially in class A. Especially in class A, because class A has been reserved for big organizations. Class A has been reserved for large organizations. Large organizations. Class C is overcrowded. That means not enough. Class C is overcrowded. So second problem we call ROADS, capital. ROADS problem. ROADS we call it road problem, running out of address space. So this 32 bits may not be enough to allocate like this. Running out of address space, that is the name of the problem. It is obvious because class A has too much, not enough organization there. Class C is too small, large number of organizations demanding that many IP addresses. Third problem is what we have just shown in the example. That means subnetting is not freely done. You can't subnet to any number of computers you want. It has to be a 2 to the power. Minimum has to be a 2 to the power. Right? Number 3 is subnetting. Because subnetting is difficult to meet. It's difficult to meet user requirement. Because each subnet should have some 2 to the power n number of addresses. Should have some 2 to the power n number of addresses. So those are the 3 problems. On a new line, right? However, solution called classless IP addressing. Classless IP addressing has been found to overcome this problem. Full stop. On a new paragraph, following are the advantages of doing the subnetting. Advantages of doing the subnetting in a large network. In bracket, class full or classless. We are not going to differentiate between the two. Whatever the method, we are trying to write what are the advantages of doing the subnet. So sometimes the examiner asks, why do you subnet? What is the purpose? Can you think of the purpose? When the network is too big, what happens? Performance comes down. So there may be collision problem. And in order to increase the efficiency of the network, you subdivide. When you subdivide from a router, suppose router has 4 ports, let us take a simple one, 4 ports, then each port becomes a separate broadcast domain. You can broadcast only within that without affecting the other people. That way, unnecessary packets don't go into other areas. Therefore, your network becomes more efficient, usage becomes more efficient. But for outside companies, your network will be still a single network. They don't know that you have subnet. For external companies, there is no change at all. Your addresses will remain the same as it is. For internally, you get better efficiency because you have divided the company into different broadcast domains. Maybe the finance division is one broadcast domain, engineering another. So that packets going between finance computers need not come to engineering division unnecessarily through the wire. So that way you can get much better efficiency. Much more number of packet exchanges can be done per second within the company cable network. We call it increased throughput. Throughput means more number of packets per second handled by the network. So those are the biggest advantages. Number 1. Each subnet is assigned with the subnet ID. Assigned with the subnet ID. The local router will use subnet IDs to route the traffic to only those required subnets. Number 2, reduces packet collision. 3, saves the bandwidth. In the overall network. 4, increased throughput. THROUGHPUT. Increased throughput of data. That means more data can be handled. Next one. For the rest of the internet, the company network looks as a single network. They don't see the subnet. Network looks as a single network. Next one. Insulate the overall internet. From the growth problems and routing complexity. In brackets, because the company does its internal routing. because the company does the internal routing. Because the companies will take care of their internal routing, the overall internet is not burdened now. They can minimize their planning. Otherwise, the internet engineering task force will have to plan the company routing also. Now they say, okay, you do whatever you want inside your company, we don't care, we will give one network ID for your company, which you can subdivide into sub-networks within the company. Otherwise, there is a big planning problem for the overall IETF, Internet Engineering Task Force. So that is what we said last, to insulate the internet from these growth problems, because growth is now internal to the company. They can decide how many computers, how many sub-networks they can have. Okay, so these are important points for your projects also. When you study companies for the project, think of these ideas. Have they subnetted, or what are the improvements you can propose? Those become projects. Okay, the subheading class plus addressing. Class plus addressing. Class plus addressing. In this method, you don't define any classes. Yes, right? No address classes have been defined. No address classes have been defined. In the previous method, you may remember that the subnet mask for class A and subnet mask for class B, they are different. Class A, class B, class C, class D had 4 different subnet masks. You can mention in class full method. In class full method, each subnet has 4 different. Each subnet has a different. So it has a different subnet mask. Can we write the example class A? What is subnet mask? Class A. This class A is 255.0.0.0. 255 will be for the net ID. Therefore, that should be made 255. Others are same. Class B, 255.255.0.0. 255.255.0.0. Class C, you can write 255.255.255.0. Those are the 3 mainly used by the router. But now there is no necessity, because there is no standard subnet mask like that. Here the subnet mask had fixed length, number of bits for the net ID, host ID. But in the classless addressing, the length will be variable. You can break it anywhere. 32 bits, you can break anywhere. This portion for net ID, this portion for host ID. Earlier we can't. If it is class A, only the first 8 bits. Class B, first 16 bits. They have predefined. But now, you can break it in between 8 and 16 also. 13 bit you can break and say this portion is for host, this portion is for the net. Meaning that you can break the IP address as you like. There are no preset rules. This is called variable length subnet mask, VLSM, variable length subnet mask. Right? With classless addressing. Classless addressing. We can use VLSM concept. In bracket variable length subnet mask. variable length subnet mask. Now the IP address can be divided at any point for net ID portion and the host ID portion. In addition, different subnets in the same network may use different subnet masks as well. Earlier we could not know. Earlier single subnet mask has to be applied for every port. Now for every port you can have a different subnet mask. Right? That means for each port of the router different subnet mask can be assigned. But planning is more tricky now. Although you can very efficiently utilize the address space, the network administrator will have to plan very carefully. So you may say advantage, address space is better utilized. If you have an address range, you can fully utilize. Disadvantage, the network administrator should do careful planning first. The VLSM, next sentence, the VLSM, variable length subnet mask, has a general idea that a small subnet, some subnet of a company needs to be small. Some subnets of a company or home, right, need to be small, while some other subnets need to be bigger. Therefore, the administrator should plan subnet sizes carefully. previous sentence you can underline. That's the understanding. The company network needs subnet. Small division may have few computers. You might need a smaller subnet mask there. Some other division may have big network. So you are flexible now. You can subdivide it for any portion. Earlier, all portions had to be same. All portions had to be same earlier. If you are subdividing into 4 subnets, each subnet should have same number of IP addresses, but not necessarily anything. This is done by using the variable length subnet mask for each of the subnets. Anything you can figure out here? This is what I captured from my home ADSL router. By logging onto that, you can capture things. Maybe some ideas you can miss out of what we have learned. They have allocated me 192.168.1.3, something very similar to what we studied. 103 subnet mask for that router. That router you fit to the home, mask has been 255.255.255.0 plus C. Default gateway 192.168.1.1. Username, password, and so many other things. What are these? VPI, VCA, do you recognize? ATM. That is IPTV signal is coming via ATM virtual channels to the home through the ADSL through router. So these are all the plans you have to do in order to get IPTV. So I just wanted to show you where the theories we are discussing are getting applied. They are applied to home networks now. ADSL connections and any home networking, they are being applied. And this is part of the thing, and actually it's much longer. There were a lot of things I could not understand, so I did not copy. Some of them are already preset. I think you can see like MAC address kind of things are preset. DNS servers, everything. Somebody has to program in order to get it going. I had to meddle it that because I had a problem with an SLT could not solve. SLT had a problem of they are giving wireless route. The problem with local companies, they don't really study the user's requirement. Good example is that SLT gives the DSL router plus IPTV connection, but router is only the wired one. You can't get wireless from the SLT, that's their rule. But none of them in the SLT has figured out that people who get this connection will want the router close to the TV set. A lot of people will be at home, will be watching the TV, and internet connection is wired, so some people with the computers will have to get around while others are watching TV. So nobody has thought of that problem. That's not understanding the customer. This is still Sri Lankan problem. They have never thought about it. I called it and I asked, well, why did not you propose the wireless solution? So that wireless routers come with the antenna now, single gadget, internet can go wireless, other wired part can go to the TV. So it doesn't matter where the router is, someone in a room also can use the internet. He does not have to come with the computer to the TV, close to the TV. They have never thought of it. They said, is that a requirement? And I said that is a requirement. I think many people would have faced the problem. So why don't you market wireless router instead of the fixed router? They are buying it from ZTE. And I checked the ZTE and they are not manufacturing wireless router. So that means they have got a cheaper company to do it, because any good router company will have wireless router in their product range, but ZTE does not. So they would have got something very cheap and supply it for low cost prices. And they told me, if you want wireless, you have to put another router yourself. I think I can do it. I said I can do it anyway. I don't need to ask you. But I am asking you, can I pay you and get the wireless router from you and you will maintain it? They say, no, we can't maintain wireless router. and I think they are fast losing the business. So they have not understood the market. And I checked, several of my students are there, and I checked with them how the market is growing. And there was a boom, and now it is static. Nobody wants to buy IPC. Obvious problem. Right? Not understanding market requirement or people's requirement. And that's not the way the technology is to be deployed. Good examples of wrong marketing and a good technology might not find a market fit. It has happened many times earlier. Good technologies, they just come and vanish because poor marketing. Same mistake same company did for the ISDN also. When ISDN came into the market, they didn't understand people's requirement. Again, not many people got ISDN. But in other countries, ISDN was heavily popular. Right? So when you get employed, don't do this mistake. Right? You may be brilliant with the technology, but if you don't understand what the other person wants, nobody will care about your company. So that shows that knowledgeable people are not there. Again, few people just introduce the product, try to see whether they can cash out some money from the people. Wrong way of thinking about the technology. Anyway, that one is useful for you, I think, because you can now see ATM. If you thought ATM is something far away, now ATM is coming to home. Because the ATM is implemented on top of this. Right, so the protocol they are using is called PPPoE, PPP over Ethernet, and they are using ATM cells in order to deliver. And VCI, VPI plans have to be there. Then I later found that I can attach another router by changing the two VCIs. I can put two VCIs, SLT will never know. Right? So it works. Later I will tell the SLT once I use it for some time. Right? So those are the things. Now ATM we did before this, and IP we are doing now. And you can now see how home products have been developed by combining these technologies together. So in future, when you handle technology, you may be needed to configure these things. Configure those addresses for a user, from the user's end or from the network end. Those are the telecom jobs you will have in the future. So understand that once you learn this theory. So, because sometimes you might not have direct access to these devices to do practical. But learn from these things basically, the home networking. There again, you have to scan lots of addresses, VCIs, VPIs, etc. to get the service going. The ATM is used as the layer 2. Layer 2. And they define a virtual path for every router. Okay, so that's a word about how the ADSL services are coming. We will stop there today. Next time we will look at this technique called VLSM in detail. I just introduced it. Thank you very much.